Data types in C++. Data or values in C++ can be represented or can be viewed by the program as basic types, derived types, or custom types. Basic types are the types that come with the compiler itself, such as integer, floating point, double, character, bool, and void. Derived types are the types that are derived or created out of the basic types, such as array, pointer, and reference. And the custom types are the types that are defined by the user or programmer, such as struct, class, union, etc. Now let me jump into the editor to explain the basic types. I have this code to start with. Basic types are the types that we can use to represent the basic data, such as whole numbers and fractional number with fractional components or fractional part, or characters, or binary information, yes or yes no type information, etc. The first I'm going to talk about integer type. Int type. This is a type that is used to store the whole number data, such as -3, minus, it could be -100, -200, but without point part. -2, -1, 0, 1, 2, 3, etc. We can define a variable of integer type or variable to store integer type or whole number data using this syntax. First you need to use a keyword called int and followed by the name of the variable. You need to give the name to the variable so that you can use that to access the data. Let me give a name x here. X is name. Now this is the statement that defines a variable called x to store whole number data. You can store or initialize this variable with the data by equating it to it. If I want to store the number 56 into it, then 56, or it could be -56, it could be 0, right? So this is how you initialize. So this step is called the definition, and this step is called initialization. And you can have a definition and initialization combined together. Int y equals to 56, 65. So this is a definition and initialization. Let me comment this out for a while. I don't want to use this variable. So now, and if I want to access, if I want to see what is the content of x, then I can have a cout statement to display the value of x. This will actually display the content of x, right? And after that, if you want to make change to the value, or you want to rewrite the content of x, you can just assign it to it, and then we can also see actually to check whether actually it has been written by the new number or not, or the new number has been written into it or not. Let me just switch to the terminal, compile this program G++ 23, and then my output file will be main.exe, and the source file main.cpp. So this statement will actually this command will compile. Well, I think there is one thing is missing here. I need to put this character dash before O, right? Now it will compile and link and I have this file main.exe, which was created out of that process. I want to execute it, main.exe. Now you can see x, previously it was a 56 value, and now it was rewritten, and it contains carries a 76 number. And if I actually set a fractional number into it, and it will just ignore that fractional number. For example, if I set 96 point let's say 55, if I do this, then because of the nature of this variable, it cannot store this thing after the decimal point. So it will just truncate everything, whatever number, even if it is 99, it will just truncate this, and 96 will be in the variable x. Let me see whether that is happening or not. Switching to the terminal, compilation and linking, and execution. Now you can see 96. The thing that was after the decimal point is actually not there anymore. Now this is the integer type. If you want to store this fractional number, then you can use float. This is the keyword for a floating point type. The syntax of defining a variable is same, float y, and you can set data to it, 96.99, and we can see whether that data we can get access, we can access the same data or not. So this should actually display this data correctly. Switching to the terminal, compilation and linking, and execution. You can see 96.99 is currently stored there. Now what I'm going to do is just use I want to store this data here, 12.66, then 777, and I want to see whether that data is stored or not. So let me compile it. Now it is showing 6678, right? So it looks like it's not inaccurate, because it has a way of displaying only 4 digits, so it actually automatically rounds it up. So if I want to see more bits, more bits of the more decimal places of the data that is stored, then I can set the precision. To set the precision, I need to use another library called IOmanip. This will allow me to use set precision here. Let me set precision to 10. So if I do the with this, let me see the output first, then I will talk further. Let me clear. Sorry. Now you can see the data that is displayed is 12.66777.802. Now this part is not accurate, because we set 66777.777. That means there is something missing. When that data was stored in that variable, or the memory space that is allocated for the variable, there was something missing, because which caused this part of the data to be inaccurate. The reason is that if I look at the size of the variable, size of x, this is the function size of is a function that you can use to see what is actually the size in memory space in bytes that is allocated for this variable. Let me also check the size of x and y both. uh, this is x and this is y. Let me see the size. Now you can see the size, both sides of x and y 4. 4 was x was integer type, y was a double type. So 4 byte is not sufficient to accurately store this data. So if you want to store that data accurately, then you need to use a bigger size type, which is in this case you can use double. Double is double precision floating point type. And you can create double precision variable like this, and you can just copy. Let me just copy this data into it and see whether that is accurately stored or not. Right, so let me have a cout statement to display it, z, and also I want to see the size of this variable. And so let me switch to the terminal, compile, link, and execute. Now you can see the data is stored 12.66777777. It is accurately stored in the memory space, and the reason is that the size is 8 bytes, so it has a bigger capacity, so it can store the data more precisely than the floating point type. So if you want your data to be stored with higher precision, you can use the double type. If the loss of information is okay, that is tolerable, then you can use floating point type. Now, next type I want to discuss here is character type. This is a syntax you can use to create to define character variable to store character, single character like A or B or Z or all these character can be stored. It has a capacity of 8 bits, 1 byte. Right, so you can set data like this, and you can display. I don't need to set precision here. Just display what is there. And another type I want to highlight here is the Boolean type. This is for storing binary information. It could be yes, no. It could be true, false, or it could be 0, 1, and 0. This kind of information. You can create this kind of variable using this syntax, and you can set either true or false into it, and you can display it on the using similar cout statement. So let me see the output of this code. I think I need to clear. And now you can see the character, a character was stored, and choice is 1. 1 means true and 0 means false, right? This is the way it is displayed. But if you want to actually display in the form of either true or false in this form, then you can use another manipulator that comes from this library itself. Let me switch back. So if you want to display this choice either as a true or false, Then we want to use a manipulator that comes from this library, which is std bool alpha. No, I think this this doesn't come from the library. So anyway, we have this tool available. If you have this here, insert this before the actual binary information you want to insert, then it will be displayed either as in the form of true or false form. Let me switch to the terminal. Right, so now you can see the true information is displayed here. And finally, a void type. This is a type that is a kind of incomplete type, because you cannot create a variable of void type, but you can use in several places. For example, if you want to return in the if you don't want to pass anything in the, or function doesn't receive anything, then you can use void, or if function doesn't return, you can use void here. And also this is used in while creating something called generic pointer, which is a little bit more advanced topic that I'm not going to discuss at this point. This is all about the basic types. Thank you for watching.